Okay, today I'm not actually going to talk about QUnit, but I have these 5 patterns that I want to talk about that should help you use jQuery more effectively. I selected these 5 from my work on jQuery UI, QUnit, and other projects. And to make them somewhat sticky, I came up with a few car and driving related analogies. The pictures you saw earlier were supposed to warm you up to that concept. Before we actually get to these patterns, I have a quiz for you. What do you think is the most popular jQuery version on the jQuery CDN? Is it A, 142, B, 172, 191, or 110.2? So who thinks it's A? That's a few. Okay, who thinks it's B, like 172? It seems about the same one. 191, that's much less, and 110, that's like 3 people. All right, I will give the answer later. For now, let's look at the first pattern. This is write code like you spend fuel. I adapted this from Doug Niner's write code like you spend money. When low on fuel, we don't really drive as fast as possible to get to the next gas station. But when the tank is full and we're in a hurry, we can drive a little faster. So how does this apply to JavaScript? Let me show you. In JavaScript, we have a choice when to run code. Before anything happens, on document ready, on window load, or what I usually recommend, the one down here commented as cool place. Does that work? There, this one. So if you've got too much code running too early, it will slow down loading of the page. So how can we address that? Let's look at a few examples. In this first one, there's several inputs with the autocomplete widget from jQuery attached. I can click on this first input here, start typing, and you can see it suggests something. That's the autocomplete, nothing special really. And the same works on the other inputs. So that looks pretty normal. But the special thing about this setup is that these widgets are initialized just in time, not on page load. And with a lot of elements, this is pretty important. For example, imagine this table here. Instead of just 3 rows with 1 column, it's like several columns, lots of rows. So you have like thousands of these autocomplete widgets. You don't really want to initialize all those when the page is loaded. So how does the just-in-time initialization work? It's actually pretty simple. In this example, with just a single input, we can use jQuery's run method. This is a special event handler method that makes the event handler run just once, and afterwards the handler is removed. So we don't have to check if this is running and then unbind it. jQuery will do that for us. But this is really only practical if you have a single element or just like a few, because you wouldn't really want to bind this to thousands of elements either. That would be too much overhead again. For that, we can use event delegation, which makes sense with a big table. We can just bind one event to the table, and using event delegation, capture the events on all the elements that we care about. In this case, the selector includes a class that the event handler then removes. So that way, each input is initialized only once and just in time. So the interesting parts here, the on method, to bind the focus event, specify inputs.autocomplete as a selector, and then inside that event handler, remove this autocomplete class so that while we have to keep the event handler in place, it won't match any of the initialized widgets anymore. And that principle can also be applied elsewhere. For example, for the date picker, we can pretty much do the same thing. We can use one with focus or on with focus in a selector. The only difference is that the date picker, when an input is focused, also opens up. So we can emulate that behavior when initializing the date picker by also calling the datepicker.show or the datepicker show method. That's these two here. And that way, the user can't really tell that this was only initialized when he was clicking in it and not any earlier. And in this case, the demo is pretty boring since it just looks like a normal date picker, even though it only gets initialized in the moment that I actually click on those inputs. For dialogs, the pattern can also be applied. It's again a little bit different. In this case, since dialogs almost always have some kind of trigger, we can make use of that. And then when first clicking that trigger, initializing the dialog, and if it's already initialized, just open it. And again, no surprises in this demo. This link here is supposed to open the dialog. It does, even though the dialog only gets initialized when we click on it. And one more. I think this is especially neat since it combines from event delegation it uses some form of, basically also uses event delegation. In this case, I want to initialize a form validation the first time any of the elements in that form are focused. And again, we can use one with focus. In this case, we actually have to use a special event called focus in, which jQuery happens to have some special event handling for, so that it actually can get delegated and also works in all browsers and not just IE, where it's actually natively implemented. And the cute thing is, on this demo, oh wait, what just happened? There. So now there's really just this one focus in event handler attached to this form. So if you think about it, like if I click on the submit button, it actually should trigger a click and also a submit event. But if the submit event handler from the form validation is not there yet, how can it handle the submit? But the neat thing is the focus in event gets triggered before anything else. So if I click on it, it actually initializes the form validation, handles the submit event, then the submit event is triggered, and we get to see the error messages from clicking on submitting the invalid form. In addition to these demos, I want to show you an example of lazy initialization in the wild, like from a website and not just the demo I put together for this presentation. This is a German IT news site, and instead of loading social widgets on page load, which can take can be a lot of overhead since they have usually multiple requests to other domains, and with just 3 additional widgets, they might have dozens of extra requests to other domains. So what they introduced is an extra click where you basically enable this widget first, and then you can use it to share stuff. And this is good for performance, but it's also good for privacy, since it means only when you actually want to send a request to Facebook, it'll do that. Otherwise, it'll only show this placeholder. And you can see in this tiny menu on the right, it actually allow you to pick one of these widgets to always load. So if you always want to share stuff from them on Twitter, then you don't need the extra click anymore. Coming up next, write code like you don't know the road. Write code like you don't know the road. This one is about the interaction between JavaScript, HTML, and CSS. It's pretty common to change markup to allow some change in CSS. Whenever we need a styling change, we may not have the right elements yet to do that. So we often must change the markup first. But this can actually break some brittle JavaScript code that relies on the existing markup. In this demo, and again, it's just a demo, but should be easy enough to extrapolate this to real-world use cases. In this demo, I have this little box here, and if I hover it, this handle shows up, and if I drag that handle, I can move this box around. It's let's say, it might be a dialog that's draggable or whatever else. So now I imagine this is not just a demo, but this is part of an actual application, and then you get a change request to do this, and another change request, and all of those require changing the markup of this element. And eventually, it might break the underlying JavaScript. Let's look at the code for this demo. So on top, you've got, you can see the markup that I'm using here, and below the JavaScript applied to that. And this actually used the children method to find the handle container. And in this case, it would break when the handle ends up wrapped in another element. So if we were to wrap the handle in an extra div, or have the entirety of the element wrapped in something else, this would break. And again, Dagniner called these flexible and brittle methods. So instead of using the children method, which would cause this problem, we can use the find methods to avoid this problem. And Dagniner would call these methods flexible and brittle. So for example, pref all would be more flexible and less brittle than pref, or next all better than next. Closest is most often much better than the parent method, also better than parents. In general, these are much less likely to break when making changes to the markup. And in this given example, it's really easy to apply. You really just replace the children method with the find method. And if we now were to change the markup, it doesn't really matter how much we nested, it would still eventually find this handle container. Of course, there are ways to break it anyway, but this is going to be much more flexible. Another example, here the code, like, sure you can figure out what this does. And basically, if the next sibling is a div, it was from an anchor, it would match. But if you like insert some element in between, it would break. And again, we can address that by replacing the next method with a selector with next all, and adding this colon first to only match the first div there. So then it would like skip elements until it finds a div and then only select that first one. There's also cases where you can find flexible and brittle selectors. For example, in the context of event delegation. Here, it's also often better to pick the more flexible selector since clicks really don't happen that often. In this case, it's better to match clicks based on just the href attribute instead of relying on a specific class that someone might forget about or might get changed for some other purpose. So, in short, again, write code like you don't know the road, using flexible methods and selectors, which also applies to the next pattern. Write code like you avoid traffic jams. Traffic jams are a bit like performance bottlenecks. If you always think about traffic jams, you're wasting a lot of time, since you probably can't really predict them most of the time. But of course, if we know about rush hours, then we can try to avoid those. And when it comes to jQuery and like performance bottlenecks, there are a few traffic jams that we can look out for. For example, having thousands of elements on a page will probably cause problems. Or doing lots of processing in the mouse move event, where for every pixel that you move the mouse, a lot of code runs, that will also likely cause problems. But occasionally, it's much less obvious. Here's some jQuery code that creates a list of items, which looks pretty innocent. It sets text and data for each list item, and then just each item is added to a jQuery object, which is then added to the page. So it's really just one DOM operation, like adding that final list to the page. So why would it take like over 2 seconds for just 400 items? And this was in Chrome. It's not exactly a slow browser. This would be a good opportunity to use a profiler. And when I ran into this particular problem a few months back, I could already somewhat tell where the problem was based on the like behavior of the surrounding code, or like on the behavior of the thing I was working on. So I added these profile calls around the code that I was suspecting to be at fault, but I couldn't really tell why it wasn't working as expected. Like, why was it so slow? So with the console profile and giving it a name, I could profile just exactly this code and not have like any unrelated like mouse events or something spoil my profile. I then ran the code again and looked at the profile that Chrome created. Here's a screenshot of Chrome's flame graph of that profile. And well, this is only a screenshot. Usually if you hover anything in there, it'll like show details for the particular element that you're hovering. In this case, there were like jQuery's add method was in multiple places. So I looked at that. Here are those details. And if you look here for aggregated self-time and aggregated total time, you can see that the total time is almost 2 seconds. So that's pretty high. But the self-time is only like 6 milliseconds. Like that's quite a different order of magnitude. So add itself didn't really seem at fault. But I could see in the graph that add was actually calling unique sort. So I looked at that next. That has pretty much the same total time, almost 2 seconds, but instead of 6 milliseconds, it took like 65. That's still a lot less than the 2 seconds, but it's also like almost 10 times as much as the add method. So continuing that a little further, eventually figured out that this problem I was running into was actually a pretty old problem. It has been around for a long time. And some other methods used to have this problem as well, but that actually got fixed around jQuery 1.5. And looking at the release blog post at the time, there were these graphs here. So here in blue, you can see the performance of the children method in 1.4, and in 1.5 in green, and you can see that like it got much faster. Like the higher bars are better, and the same applied to like next and also prev. Like those also got a lot faster. And what these three methods have in common, and what add still does, is they call the unique sort method, which sorts selected elements in DOM order. There are good reasons to do that, but it turned out that for like children next prev, it's actually not necessary. For add, it still happens for reasons that I didn't quite understand. And in my case, where I was just building a list in like memory and then appending to the DOM, it made no sense. So, and luckily in this case, it was easy to work around. Pretty much all I had to do was, instead of using a jQuery object to gather these items, I could just use a plain array. So like on the first variable, like var items, I just used an array instead. And then use items.push to gather these, and then you didn't even have to change the last line. The append would still work. Like jQuery knows that if you have an array of DOM elements, just pretend it's a jQuery object. Just the same thing. And in this case, like with this tiny change, it took less than 60 milliseconds. So a lot faster. So write code like you avoid traffic jams. In this case, the answer could be found in JavaScript. In other cases, we have to look a little further, which brings us to combine tools like park and write. jQuery pioneered a lot of new APIs. A lot of them are now available in the browser without any libraries, with JavaScript, for example, like query selector or query selector all, or class list. And there's one particular new API that got exposed via CSS, that's transitions. Since jQuery animations tend to be very slow on mobile devices like this little pocket computer, CSS transitions are quite valuable there. They don't really replace jQuery, but I think combining them both is very useful. Also very powerful. So again, I have a little demo. And this page here implements a custom tooltip on anchors. So if I move my mouse over these anchors, you can see they fade in, and it's like custom styling. Again, pretty simple, but it's just a demo. And I want to show you some what our options are to implement these fade animations there. Here's the CSS for a custom tooltip, which uses transitions for the fade effect. A lot of this is just general styling, but the interesting part are these like three definitions. So I set opacity for the tooltip in general to 0, and then when it's visible, using this tooltip visible class, I set it to 1. By itself, that would just like make it show up and disappear. But adding this transition property, we can animate the opacity over 400 milliseconds and use an easing so that it looks nice. Again, pretty simple, but let's also look at the JavaScript that's involved for this. Here is actually the complete code I was using for this custom tooltip demo. Pretty much all it does is creating a tooltip element, positioning it in the right place, setting the text based on the title attribute, then removing the title attribute on the original element, and once all of that is done, adding this tooltip visible class. And all that happens on the mouse enter event, and on mouse leave, the title is restored and the class is removed. Like on mouse enter, all this setup happens, add class, and on mouse leave, remove that same class. And because we have to define this transition in CSS, that's all we need. It'll work. But we can also control this transition from JavaScript. We don't have to define that in an actual CSS file. This is the same tooltip example with a little less CSS, and now using the transit plugin, which like abstracts controlling CSS transitions into a like jQuery plugin. So I can remove the transition in my CSS file, and instead of adding and removing this tooltip visible class, I specify the properties to transition in a call to the transition method, or rather the transition methods, because I'm calling it once to show it, and then again to hide it. And you can see in the first one, I'm also setting Q false to achieve the same behavior as CSS transitions, avoiding animations to queue up when hovering elements between the tooltip attached. Like if I were to move my mouse between these slots and didn't have this Q false set, then it would just keep queuing up the animation. In CSS transitions, that never happens. So I'm wondering, like, which of these should I use? I think there's a few aspects, and it might be just a matter of preference. Maybe you prefer actually to write these in CSS if you consider that more of a visual styling thing. Maybe you think it's better to have these, like, keep this in your JavaScript code, just like you may have been used to animating elements with like jQuery in JavaScript, or maybe other animation libraries. So if the rest doesn't really matter, then just pick what you prefer in like you or your team. Something a little more tangible might be a matter of control. Like if you actually need the ability to queue multiple transitions, then you can't do that with CSS transitions alone. You need something in JavaScript to do that. So like that queue false, you can set that to emulate the CSS behavior, but if you don't actually want the queuing behavior, then you can't do that with CSS alone. And a third thing to consider when you want an actual fallback, where if CSS transitions aren't supported, then like using this transit plugin, doing a fallback is really easy. And pretty much all you need is this. If transitions aren't supported, you just override that transition method with jQuery's animate method. And for example, for Alt-IE, where CSS transitions aren't supported, this works fine, and even in IE6, jQuery animations usually are pretty fast. But the thing with CSS transitions, since they actually have an inherent fallback where you just get just a style changed, you don't necessarily need the animation. That most of the time is good enough, and you don't really need like to have it also animate in IE6. There's one exception I know of where it's impossible to implement the animation with just CSS about page scroll. Again, that same demo, if I actually click on this button, it's supposed to scroll down the page and do that with an animation. You can see that doesn't just jump down, just actually animates the scrolling. And that's impossible to implement with just CSS. And with jQuery, we can do that. The way to do it is a little bit convoluted. We need to select both these elements and then set the scroll top to animate it to some place. And if we do it like this, this callback actually runs twice. So the really correct way to do this is actually still a little bit more complicated. Using the promise method on jQuery objects, we can, by default, get access to jQuery's animation queue. And calling the then method, we can then bind a callback to the animation queue to run when everything is done. And unfortunately, there's really no way to detect if the browser supports page scroll directly on the body or HTML element. So pretty much, it looks like we'll have to stick with this pattern forever, until like all the browsers that don't do this properly are gone. Which brings us to the fifth and last pattern: customize widgets like customizing a car. These days, you can just pretty much these days, you can pick much more than just the color when buying a car. And new or used, you can customize a lot yourself, like custom spoilers. They're awesome. So how does this apply to JavaScript? For example, jQuery widgets, they come with a selection of themes. So we could pick one of those. And maybe pick one that gets close to what we're looking for, like leave it at that, or adjust some details manually. For that, I have a demo of two customized widgets from jQuery UI, tabs and datepicker. Here, the tabs widget on the top has like 3 tabs, and on the on the first tab, there's this date picker, and it's using the Flick theme without any modifications. It's just the Flick theme as you find it on theme roller on jQuery.com. And in the second demo, I modified that a little bit to make the headers stand out more, to remove some spacing on the date picker. It's just a few lines of CSS, nothing magic really, and it works just the same. I still use the Flick theme, but I add some custom CSS. If I go back, the difference is not giant, but I think the second one looks a lot better. And that's what visual design is often about, just tiny details. Here's an edited screenshot to show you the components are selected for this demo. So at the bottom you can see I picked the Flick theme, and I picked the tabs and date picker widgets to get a custom download which contained just the stuff that I needed. So if someone tells you jQuery is bloated and it's so giant, it's probably because they never bothered to actually just pick the things that they need. If you complete everything and you only use one widget, of course it's way too much code. But that should be applied all the time. But when it comes to theming, there's a few more things. So we have a few options for CSS customization using jQuery and probably a lot of other comparable frameworks as well. I'm just using this as an example again. So when you don't really want to use any of the stock themes, like Flick or the smoothest theme, you can use the theme roller tool that we have to customize one of those. That usually only gets you so far. There's some options to configure it, but you can't really change everything. But oftentimes it might be enough. You could also use one of the stock themes, maybe modify it with theme roller, and then create your own simple style sheet to do some overrides like I did in that demo just now. Or you could use the structure files, which jQuery keeps separate from the actual theme, and then write a custom theme on top. I'm going to show you some examples of that. Or you could just write everything from scratch. Don't use any of this theme that jQuery provides. Just use for example, the date picker widget, just the JavaScript, and then theme it however you want. Then you don't have anything to override. It's usually the most work, but it also gives you the most control. Yeah, that's the everything from scratch. So here's an example from my Balsamic, which is a tool for creating mockups. You can see here a customized menu, it's a regular jQuery UI menu with some customizations to show icons and these little shortcuts to change the project styles, like the little booklets at the bottom. And this actually uses the structure CSS from jQuery, but uses a fully customized theme. They also use custom tooltips, like at the top right, there's these tiny icons. When you hover over them, it shows this tooltip. Or they have this custom dialog. There's 2 tabs embedded into the dialog header to save some space. They also have this slider in this access menu. That's like a regular slider, but then it's customized with extra labels for each step. And while the slider itself looks pretty simple, it still has all the keyboard support and accessibility, and you wouldn't really want to implement that from scratch. So really, these are all examples of widgets where you can make them look however you want, but then profit from the great user experience and accessibility that they provide. Here's a stock date picker with a fully custom theme embedded in custom calendar control. You can see some of the calendar. So this one doesn't actually use any of the original CSS. Their designer threw that away and they just wrote a completely custom theme. And this is another example on the booking side, also using the jQuery date picker, but using their own fully customized theme. And you can still see the basic layout, with the next prev months buttons and the grid. Well, it's the same, but that's really all it has in common with the default theme. A few more things. If you don't like any of the theme roller themes and don't want to build your own, there are a few more options. For example, Witchmo provides several good themes like Aristo. You can see the examples at the bottom here, or this Midnight theme if you like it more dark. They've got a lot more themes and a lot more custom widgets as well. If you're looking for something that jQuery doesn't provide, maybe Witchmo has it. All that to say, unless building widgets is your core business, like that is for jQuery or Witchmo or whoever, you really shouldn't waste your time building widgets from scratch, just like you wouldn't build a car from scratch. That would be horrible. Unless maybe you're a student and try to learn how to build a car, but that's probably not your job. So don't waste your time on like building stuff from scratch when you can just use something that already exists and then you can customize. Which brings us almost to the end, so it's finally time to resolve the quiz. I hope you're excited. Since everyone who guessed C, and that was very few people, was actually right. This is like the number one. And by the way, the top file here, 191 min.js, had within 1 month 1.5 billion hits, which used 45 terabytes of bandwidth. With that out of the way, I'd like to quickly recap what we looked at. Write code like you spend fuel, like plan ahead, spend as necessary, and keep a reserve. Write code like you don't know the road, be flexible, avoid brittle methods and selectors. Write code like you avoid traffic jams, avoid JavaScript rush hours, use a profiler when you run into unexpected bottlenecks. Combine tools like you park and ride. Make use of CSS transitions and combine them with jQuery. Customize widgets like customizing a car. Like, don't build widgets from scratch when you can customize them. Here are my contact details and links to slides and resources. And with that, thank you very much.